we're given this quadratic sequence, and then we are asked to find the next two terms. But I'm going to start with question 2.1.2, which says find the general term in this form. So what I'll do, I'm going to do this one first. So you say 234 minus 261, it gives us what? Negative 27. 261 minus 290, it gives us what? Negative 34. And then 290, negative 29. Negative 29, and then 290 minus 321 gives us negative 31. And then you find the difference of between negative 27 minus 29 gives us 2. And then negative 29 minus negative 31 gives us 2. So we know that 2a will be equal to this number here, goes to 2. So divide by 2, divide by 2. Our a will be equal to 1. And then 3a plus b is equal to this number here, negative 31. So our a is 1 plus b is equal to negative 31. So b will be equal to negative 31 minus 3, which b will be equal to negative 34. And then to find our c, we'll say a plus b plus c is equal to this number here, 3, 2, 1. So our a is 1, our b is negative 34, plus c is equal to 3, 2, 1. So c will be equal to 3, 2, 1. This will give us what? Negative 33. Negative 33. Correct. C will be equal to, positive 33, not negative. Positive 33. And then c, because this is negative and comes this side, becomes positive. So c will be equal to 3, 5, 4. So this is your c, this is your b, and this is your a. So substituting everything into our formula, we'll have Tn is equals to n squared, there's a 1 here, minus 34n plus 354. So this here will be our equation. Now we're going to use this equation to solve for the next two terms. So I'll have this is T1, this is T2, T3, T4. So the next two terms will be T5 and T6. So my T5, I'll have n squared minus 34n plus 354. So my n is 5 squared minus 34, 5 plus 354. This will give me, I'll put this in my calculator and then I'll get 209. And then for T6, I'll put 6 here, 6 squared minus 34, 6 plus 354. So my T6 will be equal to 186. So these are my final answers here. Alright, cool. So that was 2.1, 2.1.1 and 2.1.2. So now we're going to do 2.1.3. Alright, 2.1.3, they are saying that which term of the sequence will have a value of 74. So 2.1.3, they want to know if Tn is equals to 74, what term is this, right? Which means you have to find the n that you're going to look for the n. So we already know that Tn is what? N squared minus 34 n plus 354. And we'll say this is equal to 74. So now we're going to solve for n. So n squared minus 34n plus 354, we bring this to the side, so it'll be minus 74 is equals to 0. N squared minus 34n, 354 minus 74 gives us positive 280. So it's positive 280 is equals to 0. So now I have to factorize this to find my value of n. So when I factorize that, I have this will be n n, and then here minus 40, minus 20, and then you can check this out by multiplying out and seeing if you will get the same answer here, or you can just use your calculator to solve, or quadratic equation to solve for your n, quadratic formula to solve for your n. So now we see that n minus 14 is equals to 0, or n minus 20 is equals to 0. So n will be equal to 40, or n will be equal to 20. So here, this will be your answer for your n. So it says which terms, which is sort of like a hint to say that maybe you have two terms instead of one. So these are the two terms. All right, cool. So now 2.1.4, it says which term in the sequence has the least value? Which term has the least value? So they want to know the smallest, if you have this, okay, let me just do it for you. So we are given that Tn is equals to n squared minus 34n plus 354, right? So before I carry on, I'm going to complete the square and then factorize this using completing the square. So what will happen, I'll say n squared minus 34n plus 354 is equals to 0, and then I'll say n squared minus 34n is equals to minus 354, n squared minus 34n plus negative 34 over 2 squared is equal to minus 354 plus negative 34 squared, like that, right? And then I'll open my bracket and have n minus 34 over 2 squared is equals to negative 354 plus gonna add this here. Okay, let me just write it down first. Plus negative 34 over 2 squared. So n minus this will give me negative 17 squared, which is equal to this will give me negative 34 over 2 squared. So this will give me negative 65. So n minus 17 squared plus 65 will be equal to 0. So now this is equal to Tn. So n minus 17 squared plus 65. So now here we can see that we are adding something, right, to 65. So which means we're going to keep adding to 65, keep adding to 65, keep adding on 65, please, which means that 65 will be the smallest value. Okay, so 65 will be the smallest value because we're adding something to 65, which means that this 65 is the smallest value, but which n will give us 65. So if we say T17, which is equal to 17 minus 17 squared plus 65, then this becomes 0 plus 65, which means that T17 is 65. So the term that will give us the least value will be T17. Alright, cool. We are given a geometric series. We've got 5 over 8 plus 5 over 16 plus 5 over 32 plus, and I say this is equal to k. Right? They say determine the value of k if the series has 21 terms. So in order to do this, 2.2.1, we have to find our a and our r. Our a we know is what? 5 over 8. And then our r is a is the first term, right? And then r will be t2 divided by t1 which is also equal to T3 divided by T2. So to find our R, we'll say 5 over 16 divided by 5 over 8, and that will give us a half. So you can just do this in your calculator and it gives us a half. So to find the value of k, we'll say Sn is equals to k, right? The sum of the 21 numbers, right, is equals to k. 21 terms will be equal to k. We know our formula for this will be S. It's A R n minus 1 r minus 1. So we have to find our a. Our a is 5 over 8. We found that. Our r is half the power of n minus 1 divided by half minus 1, and this is our Sn. So for S21, sum of the first 21 numbers so that we can find the value of k will be 5 over 8, a half 21 minus 1 divided by a half minus 1. So we put this in our calculator and then we'll find the value of k. So we'll say 5 over 8 half 21 minus 1 divided by half minus 1. This gives us what? Minus 2,25. So that will be your solution. So k will be equal to minus 2,25. So that's our solution for k. Alright, now moving on to 2.2.2. So 2.2.2, we are given that Tn is greater than 5, and then this is 8192. So we have to find the largest value of n for which this holds, right? So we know Tn is what? Arn minus 1 for a geometric series, right? It's 192. Our a is 5 over 8. Our r is half. And then we've got n minus 1 is greater than 58192. So I'm going to apply exponential law to this. Say 5 over 8 half n times half power of negative 1 is greater than 58192. Okay, I'm going to continue on this side. So I'm going to multiply this and this here. So that will be 5 over 8 times a half to the power of negative 1. And this gives me 5 over 4. So it's 5 over 4. And then half n is equals to 58192. Going to times both sides by 4 over 5 times 4 over 5. Then this will give me half the power of n not equal to greater than. So 5. This will be 8192 times 4 over 5 gives me what? 1 over 2048. And then we know that this can be written as 2 to the power of 11, and this is just a half, right? And then anything 1 to the power of any number is 1, so this will be 1 over 2, 11, and then half n like this. So n will be greater than 11, and that's your final answer there. So right, cool. That's the end of question 2.